Today our focus shifts just slightly to what we call dependent and independent events. Let's start off with getting some definitions. What we mean by independent events are two events that are independent if the occurrence of one does not affect the probability of the second event occurring. So for example, the probability of my choosing to go to the mall to go shopping has no bearing on whether Miss Beebe makes the choice to go to the mall to go shopping, unless we're making plans together, and then that's a different situation. And in this case, we take the probability of each independent event and we multiply them together to give our total probability of them both happening. Independent events, on the other hand, are if the occurrence of one event does affect the probability of the second event occurring. So then that would be, for instance, if I said I want to know the probability of my getting my work done and the probability of my being able to go to bed early. One of them plays the effect of the other, because if I don't get my work done, I'm not going to be going to bed early. So then we take the probability of A happening times the probability of B happening, assuming A has already happened. So our first focus is going to be to look at finding the probability of two independent events. So we have a spinner here that has, we're going to spin it twice, and it has 12 equal sized sections numbered 1 through 12. And I want to know the probability of spinning a 2 and spinning a 5. This is an independent event because what I spin on the first spin and what I spin on the second spin have no bearing on each other. So what we're going to do is first find the probability that A will occur. So what we're going to find is the probability of getting a 2, and we're going to then find, step 2, we'll leave it at B to find the probability of B, and then we'll multiply the two probabilities together. So we're going to take the probability of 2 times the probability of getting a 5. And so the probability of spinning a 2 is 1 out of 12. And the probability of spinning a 5 is also 1 out of 12, which when I multiply those together, I get 1 out of 144. Now to remember, to turn that into a decimal, we will take our 1 and divide it by 144. And then to get a percent, we're going to move it 2 places to the right. I'm going to leave you to do that. I will expect to see that in your notes. Our second one, a multiple of 2 and a 5. So that means that we're going to take the probability of a multiple of 2 times the probability of a 5, which we know the probability of 5 is already 1 out of 12. The multiple of 2, I look here and I see that 2, 4, 12, 6, 10, 8 are all multiples of 2. So I take 1, 2, 3, 4, 5, 6. So that's 6 out of 12. One thing I know is that 6 out of 12 is equal to 1/2. So 1/2 times 1/12 is going to be 1/24. And I will leave you to get the decimal and fraction equivalents. The next one, probability of an even number and a blue. So I look here, probability of an even times the probability of blue. Probability of an even number, we have 2, 4, 6, 8, 10, 12. That is 6 of them, so that's 1/2 of them are even. Probability of a blue, I also have 1/2 that are blue, because there's 6 out of 12. 1/2 times 1/2 is 1/4. This one's an easy one to do, so we're going to do 0.25, and that's equal to 25%. Looking at another example, I want you to go ahead and try this one on your own. Enter your answer into Edpuzzle, and then press play to check your answer. All right, let's check your work to see how you did. We roll in a red number cube and a blue number cube. These two events are independent of each other because what I roll on one has no bearing on what I roll on the other. So with having a probability of a red 3, we've got probability of a 3 on red times the probability of even on the blue. The probability of rolling a 3 on the red is a 1 out of 6 chance because it is a standard number cube. And the probability of rolling an even number is either 2, 4, or 6. That's 3 out of 6, which is 1/2. So 1/6 times 1/2 is going to be 1/12. And if we want to look at it to find our decimal and fraction equivalents, we take 1 divided by 12 and we get 0.083 approximately, which is approximately equal to 8.3%. When you go out 3 decimal places, so that way you have it to the nearest tenth of a percent. When we look at probability of getting a 5 on the red and on the blue, a 1 or a 2, we take these, we multiply, and probability of getting a 5 on the red is a 1 in 6 chance. The probability of getting a 1 or a 2 on blue would be a 2 out of 6 chance, which is 1/3. So 1/6 times 1/3, which equals 1/18. And 1/18, if we do that on a calculator, we get 1 divided by 18, and you get 0.056 rounded to the nearest tenth because it's 0.5 repeating. And then you take that, move it 2 decimal places to the right, which equals 5.6%. The final one, probability of red and blue prime numbers. That means that we want the probability of a prime on red times the probability of a prime on blue. Well, prime numbers from 1 to 6 are 2, 3, 5. So that's 1/2 times 1/2, which equals 1/4, which, as we know, 1/4 is 0.25, which is 25%. Hope you did well. Let's move on to one. It's a little bit different. Now we've got Hayden and Crosby hitting balls that their dad's pitching to them. Hayden hits 70% and Crosby hits 35%. So now we're looking in terms of percentages. So probability of Hayden and Crosby, these are independent events because what happens in the event of Hayden getting pitched to and what happens when Crosby gets pitched to are 2 very different things. So here we're going to take the probability of Hayden getting a hit times the probability of Crosby getting a hit. I'm going to, since my percentages are what was given to me, I'm going to turn those into decimals. So this is going to be a 0.70 times 0.35. And if I take 0.7 times 0.35, I get 0.245, which is equal to 24.5%. If it gives you as a percent, your answer needs to be in a percent. If I ask you to give all 3, then obviously you give all 3. And then that would be easier to change 0.70 and 0.35 into fractions first. Now, this new one has this new little apostrophe. This is what we call not or a complement. And so what I'm going to find here is the probability of Crosby getting a hit times the probability of Hayden not getting a hit. So probability of Crosby getting a hit is 0.35. Probability of Hayden getting a hit is 0.7, which means that 0.3, because this I've got from taking 1 minus 0.7, because 1, remember, is 100% probability, and 100% minus 70% is 30%. So we have 0.35 times 0.3, and if I take 0.35 times 0.3, I get 0.105, which is equal to a 10.5% chance that Crosby will get a hit, but not Hayden. Now, the probability of Crosby getting a hit and then getting another pitch and not getting a hit So this is going to be, probability of Crosby getting a hit is 0.35 times the probability of Crosby not getting a hit is 0.65 because 1 minus 0.35 is equal to 0.65. And then if I take 0.35 times 0.65, I get 0.2275, which is 22 3/4 or 22.75%.